Hello students, welcome to my channel Positron. Today's topic, this is going to be my first video, second video. First video was dedicated to the system of units, fundamental quantities, and today's topic is error analysis. Question is that, why do we study error in physics? Dear students, if an experiment is carried by many of the expert people, then all the expert people, despite taking all the cares, they will not get the same result. Then if all of them has not got the same result, then you cannot say that everyone is wrong. It means this proves that error is bound to come in the physics. In experiment, error is bound to come. So there should be a permissible error in an experiment. That is why we do study the error analysis. Now, dear students, error is basically divided into two types. Error is divided into two types. One is a systematic error, and another is a random error. Systematic error means the root cause that why the error is coming and you can minimize. I will not say that you can completely eradicate that error, but you can minimize taking the precautions. The systematic error, the error why it is coming in the experiment. This is further divided into three types. The first one is that might be the instrumental error. Dear students, the error caused in the experiment due to instrument itself, that is called to be the instrumental error. Might be that the instrument you are using for the measurement is not properly calibrated. In India, weight and measurement is assessed from NPL, National Physical Laboratory, New Delhi, that controls completely the weight and measurement in our country. It might be the prototype that you have got is not properly calibrated, right? So the error caused in due to the instrument is called instrumental error. For example, if you are weighing something and the weight is not correct, not correctly calibrated, then your answer would be undoubtedly will not be true. Second one is imperfection in the technique. Imperfection in the technique. Imperfection means you are not using the proper technique, right? For example, the doctors in hurry what used to do that for measuring the body temperature, the right thing is that the thermometer should be kept below your tongue. Only then you will get the body temperature. But oftenly doctors used to put the thermometer just below the armpit, and in that case you will not get the real value, right? And first one is instrumental error. That error caused due to the error in the instrument. Means is your instrument you are using for the measurement is not properly calibrated. Second one is imperfection in technique, means the technique you are applying is not the perfect. And third one is a personal error. Dear student, personal error is what? The error made by ourselves, made by me, made by the person who is carrying on the experiment is said to be the personal error. Means the error caused due to the individual one is called personal error. How does it come? For example, if you are measuring a distance, if you are just measuring a line segment, then what should be the proper technique is that if this is the scale, then your head should be just above the scale, only then you will read the proper value. But if a bit you are left or right, then there will be a change of 1 mm might be in the measurement, right? If let you are the right value is at 2.3 centimeter, then you might measure 2.4 centimeter or 2.2 centimeter, because your head is not just above the scale. If your head is either a bit left or a bit right, then you will not read the proper value, and this is called actually parallax. This is a parallax, right? So the dear students, what I have said, that error is basically divided systematic. The error is divided into two types. One is a systematic error and that is a instrumental error. Systematic error is further divided into three types: instrumental error, imperfection in technique, and third one is a personal error. Instrumental error means the instrument that you are using for the measurement is not properly calibrated, then it is said to be the instrumental error. For example, in our country, the National Physical Laboratory, New Delhi, is responsible for the weight and measurement. It means whatever weight we use, that should be properly calibrated and stamped from NPL New Delhi. If it is not properly calibrated, then it will not give you the true value. Second one is imperfection in the technique, means you are not using the right technique in the experiment. And third one is a personal error. It is said that if you are carrying on the experiment of physics, you should be relaxed, you should be patient enough, right? And if you are in hurry, because the most of the experiment in physics takes 2-3 hours, if you are in hurry, then you will never get the right value, right result. So that is called personal error. So these are altogether you can say it is a systematic error. Systematic error means the root cause of the error you know. Why does this error is coming in the experiment, you know. You can take precaution. You can minimize these errors by taking the right instrument, by using the perfect technique, and personal error, you can avoid the personal error, be relaxed, be patient, and do easily, right? And second one is a random error. Dear student, despite taking all the cares, even then you will not get the right result. Despite taking all the cares, even then you will not get the right result. It means again the error is coming. Then what kind of error is that? That is said to be the random error. Means that despite taking all the cares, if the error is coming and that error, you do not know the root cause of that error, that is called to be the random error. So this is the type of error. Now let's move further. Dear students, let's move further type of error. One is a very important error, that is said to be the least count error. Least count error. This is very important in physics. First, let us discuss that what is called least count. What is called least count? The minimum exact measurable value from an experiment is said to be the least count. Minimum exact measurable value from an instrument is called the least count of that instrument. For example, the three instruments I am considering, one is a meter scale, another is a vernier scale, and third one is a screw gauge. Dear students, three instruments I have considered here. One is a meter scale, second one is a vernier scale, and third one is a screw gauge. Meter scale, the least count of meter scale is a 0.1 centimeter. 0.1 centimeter means the minimum exact distance you can measure using meter scale is a 0.1 centimeter. Vernier scale has the least count 0.01 centimeter, whereas the screw gauge has the least count 0.001 centimeter. Right? We are studying least count error. I am trying to let you understand that what the least count error is. First, we should know that what is the least count. I have said just a few moments before. Least count is what? The minimum exact measurable quantity is said to be the least count. From the meter scale has a least count 0.1 centimeter, means using the meter scale, the exact measurement, that minimum exact measurement you can do is a 0.1 centimeter. Vernier scale has a least count 0.01 centimeter, and screw gauge has the least count 0.001 centimeter. Dear students, before going on this topic, let us discuss one thing is a very important, that is a perception, and just after this we will discuss. Now, what I have said that least count error we are studying, least count is the minimum exact measurable physical quantity from an instrument is said to be the least count. I'm here three instruments used for the measurement of length. First one is a meter scale, which has the least count 0.1 centimeter. Vernier scale has the least count 0.01 centimeter, and screw gauge has the least count, that is 0.001 centimeter. If the least count is smaller, then error will be minimum. That means more precise measurement it will be. That is why just I am saying that the two words I am using here, one is a precision and accuracy. What is means of that? Let the value of a small g at your place is 9.81 meter per second square. I am giving you the example. Let the value of a small g acceleration due to gravity at a place from where you are watching my videos is 9.81 meter per second square. Is small g at your place, right? Let one student has got this value 9.79 meter per second square, right? And another one has got, second student has got 9.8. Another one has got 9.8. That is, this values you can say, this value is 9.59, but another one has got 9.8. Now, what is the difference between these two values? Look here, what I am saying, I am trying to let you understand that what is the difference between precision and accuracy, right? The value of small g at your place from where you are watching my videos is 9.81 meter per second square. Two students has carried on the experiment. One has got this value 9.59 meter per second square, and another has got 9.8 meter per second square. Now compare these two values. This value undoubtedly is a more closer to the true value, right? This value is more closer to the true value of the experiment. It means this is more accurate, but this is up to 2 points of decimal, and it is only up to 1 point of decimal, so it is more precise, but it is more accurate. So accuracy means how much close your value is to the experimental or true value of that experiment, and precise is that up to how much points after how many points after the decimal you have got the value. Here up to 2 points after the decimal you have got the value, and in this one up to 1 point after the decimal you have got the value. So it is there the 2 points up after the decimal, that is why it is more precise, but it is more closer to the true value, so it is more accurate and it is more precise value. Now dear students, how does it has the least count error, how does it has the impact on your experiment? Now for example, because if we are using the meter scale, then up to the 1 point after the decimal you can get the value. For example, a value is a 3.1 centimeter. Using meter scale you have got. Just I am trying to compare that. If more precise instrument you use, then the least count error will be minimized. How? Look, you used meter scale, you know it has the least count 0.1 centimeter. It means up to the 1 point of the decimal you will get the value, and you measured a length that works out to be 3.1 centimeter. Now the least count error, dear student, least count error in this value will be, least count is a 0.1 divided by value into 100. This would be cancelled. 31 3 that is 93.70, right? 31 2 this percent. You will get the least count is error is 3.2%. Now dear student, let the same measurement is done by vernier scale, right? And this time you have got the value. You will get the value up to 2 point of decimal. Let the value is this time 3.14. So least count error, this time least count is a 0.01 divided by value into 100. This will be cancelled. Now here it was 100 by 31, it is 100 by 314, and that will be undoubtedly 0.3% like this. Now third time further you are using that, it was vernier scale. From the when you are using the meter scale, the least count error works out to be 3.2%. When you use vernier scale, the least count error is a 0.3%. And now the least but not last, you use screw gauge. Now you know the least count of the screw gauge is 0.001 centimeter, means any value, any length you will measure, there will be 3 points after the decimal. So this value you have got this value 3.143. So the least count error in this value, least count error this time will be, that is least count 0.001 divided by the value and multiplied by the 100. Now it will be 0.03%, near about. Now look here, when you used meter scale for a measurement, least count works out to be 3% approximately. And the least count was up to the 1 point of decimal, 0.1 centimeter. Now you used a vernier scale for the same measurement and you have got the value. This time you have got the value 3.14 and least count error becomes 0.3%, means 1 by 10 of previous value. Dear student, now you use more precise, that is a screw gauge, and the value you get, that is 3.143. Least count will be 0.001, and in this case least count error is a 0.03%. It means here it has a least count 0.1 centimeter. It is more precise than that. Vernier scale has a least count 0.01 centimeter, and the screw gauge has the least count 0.001 centimeter. Most precise in all the three, right? In this case, error was nearly 3%. Then when you use more precise than that, error becomes 0.3%, and ultimately when you use screw gauge, the error becomes 0.03%, means error has become 1 by 10, 1 by 10, so on. Here the least count was up to the 1 point of decimal, it is up to the 2 point of decimal, and it is up to the 3 point of decimal. It means screw gauge has the least count up to 3 point of decimal, so you can say that screw gauge is more precise than vernier scale, and which is more precise than meter scale. Dear students, let's move further. Further is a calculation of error, or you can write relative error, absolute error, and percentage error. Relative error, absolute error, and percentage error. Dear student, let an experiment is carried by many of the expert people, and those expert people have got the value in the experiment. First one has got A1, second one has got A2, third one has got A3, dot. Right? What I'm saying, that let an experiment is carried by n people, and n expert people. First one has got the value A1, second one has got the value A2, third one has got the value A3. Now, question is that who is right, who is wrong, and who is how much right and who is how much wrong. How will you know? You must know the true value of that experiment. Here, the true value you do not know. Then how will you compare that these values are how much close to the true value? So the first challenge is to get the true value of the experiment. How you can get? Now, we will find the mean value of this, and that mean value of the experiment will behave as a true value of experiment. And mean value, you know, a mean, and that is equal to A1 plus A2 plus dot 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 An divided by n. Now this mean value, what I have said, that n expert people are carrying the same experiment at the same place. First one has got the value A1, second one has got the value A2, and third one has got value A3. Dot dot dot. Now question is that, how will you compare that? How will you say that this particular person is right, this particular person is wrong, or how much right he is or how much wrong he is? Means you should have a value from which you will compare these values. So in order to get the true value of that experiment, what I have done, I have taken the mean value of these values, and mean value is this, that is A1 plus A2 dot 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 An upon n. Now, dear students, the error in first value will be, it is the true value of experiment. The mean value is working here as a true value of the experiment. So, error in first value del A1, that is equal to A mean minus A1. Right? I am comparing with this value. This is a true value of the experiment, and I am comparing all these values with this value, and we will get the error. In second value, that is delta A2 equal to A mean minus A2. Delta A3 equal to A mean minus A3. Dot dot. Now, dear student, like here, we have got the mean value, that is working the true value of the experiment. Now, the error done by the first observer is delta A1, by the second observer delta A2, error by the third observer, that is delta A3. Now, question is that what should be the error or applicable error in that experiment? So, we will consider, for example, here to get the true value of the experiment, we have considered the mean value. In the similar way, dear students, in the similar way, in order to get the true value of the error, that what is the error permissible in the experiment, we are considering the mean error, that is delta A mean, and that is equal to delta A1 plus delta A2 plus dot 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 divided by n. This is the true value of the experiment, and this is the true error in the experiment. And dear student, relative error R is equal to, that is ratio of mean error and mean value. Ratio of mean error and mean value is the relative error, and the percentage error is what? Percentage error, that is equal to delta A mean upon A mean into 100. In this way, you can get the percentage error. In this way, you can get the percentage error in an experiment. Now, let's move further. Calculation of error. Dear students, now we are trying to find that how the error can be calculated in different physical formulas. First, in addition or subtraction. Now, dear students, let a formula is y is equal to a plus minus b. Dear student, a physical formula is given y is equal to a plus minus b, and you have to find out the error in this experiment. It means the experimental value is a y, and that depends on the two physical quantities a and b. You have to find out the value of y or error in the value of y, which depend on the two physical quantities a and b, and y is equal to a plus minus b, right? With the error you can write y plus minus delta y, that is equal to a plus minus delta a plus minus b plus minus delta b. Now dear student, look here, y is equal to a plus minus b. So here y is equal to a plus minus b. It will be cancelled. So you will be left plus minus delta y is equal to plus minus delta a plus minus delta b. Dear student, in fact error is considered only positive. So your value will be delta y is equal to delta a plus delta b. It does not matter whether it is a plus b or a minus b. If the physical formula is y is equal to a plus minus b, then the error in the experiment delta y is equal to delta a plus delta b, whether the formula is y is equal to a plus b or y is equal to a minus b. It means the error is finally added. There is no question, there is no matter whether it is a y is equal to a plus b or y is equal to a minus b. Now, for example, a problem based on this, it might be like this. Let the L1 is equal to 2 plus minus 0.1 centimeter and L2 is equal to 3 plus minus 0.2 centimeter. 2 plus minus 0.1. It means it is a value and this is the error in the value. 3 plus minus 0.2. 3 is the value and 0.2 is the error in the value, right? So if it is given that L1 plus L2 you have to do, then L1 plus L2 is equal to 3 plus 2, 5 and plus 0.2 plus 0.1, that is 0.3, and L1 minus L2 or L2 minus L1. Okay. 3 minus 2 is 1 and error again will be added, that is plus plus minus 0.3. So whether it is a y is equal to a plus b or y is equal to a minus b does not matter. Only the t value changes on based on this formula. If L1 plus L2, then 3 plus 2, 5. If L2 minus L1 or L1 minus L2, simply you have to subtract these t values, 3 minus 2, 1. And whether it is a L1 plus L2 or L1 minus L2, error you just have to add. So 0.2, 2 plus 0.1, that is 0.3, even in the case of L1 plus L2 or in the case of L2 minus L1 or L1 minus L2, it does not matter, right? Dear students, this was the formula based on either addition or subtraction. Now let's move. In case of multiplication, if a formula is based on the multiplication, for example, y is equal to a into b. The physical formula is y is equal to a into b, and now you have to find out the error. So writing this value with the error, what becomes? Y you must will write as a y plus minus delta. Plus minus means if you consider the error, means sometimes there is a possibility that result might be if error is a y plus minus delta y, it means result might be between y minus del y to y plus del y. It means what I'm trying to tell you, that why do we write error, the value with the error y plus minus delta y. Why it is? Means our result anywhere may exist between y minus del y to y plus del y. What I'm saying, that why do we write y plus minus del y? Why don't we write either y plus del y or y minus del y? Because you are studying the error. Dear students, y plus minus delta y means your result can exist anywhere between y minus del y to y plus del y, right? Now, if you write with the error to all these values, a will be written as a plus minus delta a into b plus minus delta b. Dear students, it will become y plus minus delta y, that is equal to multiply by b to all this, ab plus minus delta a into b. Now multiply to each by plus minus delta b, that is plus minus a delta b. And now when plus minus is multiplied by plus minus, result will be again plus minus, and this is delta a to delta b. Dear students, plus minus multiplied by plus minus means it may be both positive, may be both negative, may be one positive, another negative, may be first negative, other one positive. So the result you will write, if plus minus multiplied by plus minus, result will be plus minus. Dear student, delta A and delta B, it is the product of errors in A and B, right? Delta A into delta B, it is the product of error in A and B. Error is a very small quantity, less than the 1. And if the two quantity less than the 1, and if the product you are considering, it will be more or less, so it is a negligible. You can say it is a negligible. So just remove it, you will get this time this is. Now y is equal to a into b already given, so it will be cancelled. Now this is plus minus delta y is equal to plus minus delta a into b plus minus a delta b. Dear students, what I am going to do, just divide by y to whole equation. Now it is a delta y upon y, right? And I am considering, write it like delta y upon y. This is plus minus delta a into b. Divide each segment by y, right? So upon y. Here it is more relevant to write a dot b instead of y, right? What I am writing here, a dot b instead of y, because y is equal to a dot b. So it is a, instead of rather y, I'm writing here A dot B. And now here becomes plus minus A delta B divided by AB. Now look here. B will be cancelled here. A will be cancelled. So your result will be like this. That plus minus delta y upon y, that is equal to plus minus delta A upon A plus minus delta B upon B. Now you can get the maximum. This is relative error actually. This is the maximum value of error, that is a delta A upon A and plus delta B upon B. When you are considering the maximum possible value of error, and if you multiply by 100, this is maximum possible percentage error in that experiment. Now multiply each one by 100, right? Now, this is very important. Delta y upon y max into 100 means it is what it is giving to you. It is giving to you the maximum possible percentage error. This is what percentage error in A. This is what percentage error in B. It means if you know the if it is given the percentage error in A and B, then directly you can get the percentage error in the value of y. Dear student, here might be the case. Let just I'm trying to extend this one. Let A is equal to B. If A is equal to B, the formula you have considered y is equal to A dot B. If A is equal to B, then your formula will just write A here, A into A square. So here also will be A, delta A upon A into 100. So the result will be delta y upon y max into 100, that is equal to delta A upon A into 100 plus delta A upon A into 100 means 2 delta A upon A into 100. You can say that the power here appears here. If the y is equal to A to the power n, you are considering the error will be delta y upon y max into 100, that is equal to n delta A upon A into 100. Right? If the formula you are considering like this, now look here, your formula is y is equal to A to the power L, B to the power M and C to the power minus n. I have considered physical formula y is equal to A to the power L and B to the power M and C to the power minus n. Now we have to, our task is to find out the maximum possible percentage error in the value of y. The maximum possible percentage error in the value of y will be delta y upon y max into 100, that is equal to, now apply on this. What I have said, if the physical formula is A to the power n, then power n appears here, in similarly here A to the power L, so power appears here and A becomes delta A upon A into 100. Now A dot B, when y is equal to A dot B, the formula becomes, the error in y becomes delta y upon y is equal to delta A upon A plus delta B upon B. If the formula is y is equal to A dot B, A into B, the error in value of y, delta y upon y is equal to delta A upon A plus minus delta B upon B. In the similar way, here A into B, these three A, B, C are just multiplied to each other. So again here if y is equal to A dot B, delta A upon A plus delta B upon B. In similarly A to the power L into B to the power M, so it will be here plus and B to the power M, so it is M delta B upon B into 100. Now, dear student, here it is C to the power minus n. The result should be actually minus n. This minus n will be multiplied here. So, result will be minus n into delta C upon C into 100. But actually here you have written delta y upon y max, means you are considering the maximum possible percentage error. That is why what you have to do, you have to consider all the positive values. So if the formula is y is equal to a to the power l, b to the power m, c to the power minus n, then your physical formula becomes delta y upon y max equal to, max into 100 is equal to L, this power will appear here, L delta A upon A into 100 plus this power will appear M delta B upon B into 100, and this should be actually minus N delta C upon C into 100, but you are considering the maximum possible percentage error in that experiment. That is why there is no consideration of any negative value. All the errors, all the part of error could be added. So our formula becomes like this. Now, dear students, let's move further, and why it is plus, these are mutually multiplied to each other, and that is why the multiplication results into the plus if you are considering the error. Dear student, least but not last, that is a formula based on division. In case of division, dear student, question is that if a formula is based on the division, then how will you solve? How will you find out the error? Question is that if a physical formula is based on the division, then how will you find out the error? Let's consider, let a formula is y is equal to a upon b. Right? The formula I have considered, y is equal to a upon b. Let's write with the error. This becomes y plus minus delta y, that is equal to a plus minus delta a upon b plus minus delta b. Dear students, nothing special I have done. Simply I have written the formula. It's a given, right? I am not considering myself. Let a formula is of this type, y is equal to a upon b. Y is depending on two physical quantities a and b, and that is y is equal to a upon b. With the error, I have written the formula y plus minus delta y is equal to a plus minus delta a divided by b plus minus delta b. Dear students, one thing very important we will use here, that is said to be the binomial first order approximation. What it is? 1 plus x to the power n. If it is given 1 plus x to the power n, that works out to be 1 plus nx if n and x both are less than 1. If 1 plus x to the power n, a formula is given in the form 1 plus x to the power n, you can write it, you can just approximate it in the terms 1 plus nx, but the condition is that n and x both should be less than 1. Now look here, our formula is y plus minus delta y is equal to a plus minus delta a, b plus minus this. Now y plus minus delta y, that is equal to a plus minus delta a. Dear student, bring it to the numerator, then it will turn b plus minus delta b. Now y plus minus delta y. What I am doing here, I am just considering a out, common. So it will become 1 plus minus delta a upon a. If you are confused, then again multiply by a. So it will turn a into 1a plus minus a into that much, a will be cancelled, delta a would be left. It means you have taken right common, because if you multiply by that, and the same result you will get. In the similar way, it's the inverse. Please, sorry. You have brought this term in the numerator, so it will become power. Here is the power 1. When you will bring this to the numerator, it will become b plus minus delta b to the power minus 1. Dear student, now look here. It is just applying the first order binomial expansion. It will, but you cannot apply right now. It is 1 plus x to the power n, and here it is b plus minus delta b. So what you have to do, look here, if it is b plus minus delta b inverse, what I'm doing, take b common, it will be 1 plus minus delta b upon b whole power minus 1. Now again if you multiply by the b, same result you will get b plus minus delta b. It means it does not have any impact. You can do like this. Now just open this, b whole to the power minus 1. So this power will appear on each, b to the power minus 1 if you open this, and this is 1 plus minus delta b upon b inverse. Now it is b minus 1 means 1 upon b, and it will be 1. Now dear students, this is n less than 1, and this one is a delta b divided by error divided by its true value. It is less than 1. So it will become delta b divided by the true value, and error delta b upon b is what? An error divided by its true value. So it will be less than the 1, and that is why now this time you can apply the binomial here. Here it was less than the minus 1, but I didn't apply the binomial. Why? Because it was b plus minus delta b. For the first order binomial expansion, you should have a formula in the form of 1 plus x to the power n. That is why b I have taken out, and now it becomes 1 plus minus x to the power n. So it will become 1 plus minus. If you will multiply by minus 1, then plus will turn minus and minus will turn plus. So again it will be plus minus. What I am saying, it will become 1 plus minus nx. N is a minus 1. So if here you consider plus, multiply by minus, then it will be minus and minus will be plus. So it is ultimately you will get plus minus. That is why I am writing plus minus delta b upon b. Minus 1 I have multiplied here. Why? Because I have used first order binomial expansion, and that says 1 plus x to the power n is equal to 1 plus nx if n and x both are less than the 1. And now dear students, from this can be written in this form, and I am using the same here. It is 1 upon b means this, and now it is 1 plus minus delta b upon b. Now dear student, if you take y here common, so it is y common, 1 plus minus delta y upon y. Now y is equal to a upon b, both the sides will be cancelled, right? So y is equal to a upon b, it will be cancelled, and finally you will get 1 plus minus delta y upon y, and that is equal to 1 plus minus delta a upon a multiplied by 1 plus minus delta b upon b. Now open it, 1 plus minus delta y upon y, multiply by 1 to each of that term, you will get 1 plus minus delta a upon a, and now multiply by this term to all this, that is plus minus delta b upon b multiplied by 1, that is plus minus delta b upon b, and this again plus minus multiplied by plus minus will result plus minus, and this multiplication will result delta a delta b divided by ab. Now dear student, again I am applying the same idea. Delta a into delta a is the error in a, that is less than the 1. Delta b is the error in b, much less than the 1, and if you multiply very small quantities, it will turn a smaller one. That is delta a into delta b is a very small quantity. So this, and ultimately it is being divided by ab, so it will become much smaller, so it can be neglected, right? It is a negligible quantity. So ultimately what I'm just removing it, and now 1 will be cancelled. Now considering the maximum possible error, that is delta a upon a plus delta b upon b. In order to get the maximum possible percentage error, I am just multiplying by 100 both the sides, and this is the maximum possible percentage error, that is delta y upon y into 100 is equal delta a upon a into 100 plus delta b upon b into 100. Similar to the formula of addition and subtraction, whether it is a y is equal to a plus b or y is equal to a minus b, DI student, error in the value of y works out to be delta y is equal to a plus minus a plus delta b, delta a plus delta b. What I am trying to tell you, that whether the physical formula is given in the form of y is equal to a plus b or y is equal to a minus b is immaterial. The error in the formula will be delta y is equal to delta a plus delta b in both the cases, whether it is a case of addition or subtraction. In the similar way, whether it is a formula is given y is equal to a into b, product of two physical quantities, or division of two physical quantities, y is equal to a upon b, in both the cases error works out to be delta y upon y max into 100 is equal to delta a upon a into 100 plus delta b upon b into 100. I mean to say, whether the formula is y is equal to a into b or y is equal to a upon b, in both the cases maximum possible percentage error works out to be delta y upon y max into 100 is equal to delta a upon a into 100 plus delta b upon b into 100. With these words, I say goodbye to you all. Dear students, it's my request to you, my special request, a request that I'm making from deep and sincere of my heart. If you think that my videos are going to be beneficial to you, then please and please like, share, subscribe and comment, and must put the bell icon so that you can be notified, you can get the notification of my new videos. I'm sure just within 1 or 2 days you will get the next video that must be based on the dimensional analysis. Okay, till then, bye.